For this lesson, we're looking at exponential equations. We'll jump straight into some examples and you'll get an idea of how to solve them pretty quickly. Over here, we've got 2 to the power of y is equal to 2 to the power of 4. Now you can see on both sides, you've got exactly the same base value. These values are 2, these larger numbers here, are called the base. And in all of these questions for these exponential equations, you're always going to be searching to get the same base on the left-hand side and the right-hand side. That's the key. Now over here we've got the power of 4 and you've got the power of y. Now for these to be equal, y must be 4, so straight away we can get our answer and say that y is equal to 4. So let's solve that straight away. Now over here it gets a little bit trickier because we don't have the same base. We've got 2 to the power of x is equal to 8. If you want, you could say it's 8 to the power of 1, but there's no real need. What we need to do is get the same base. So you need to make this 2 to the power of x is equal to 2 to the power of something. What would that something be right here so that we get the value of 8 on the right hand side? Well, you might recognize that 2 to the power of 3, or 2 times 2 times 2 gives you 8. So right now we've got the same base on either side, so we can say that x equals 3. Straight away you can see your powers of the top ones there. Now for this one here, you can see we've got 4 to the power of 3 equals 8 to the power of m. Over here for this 8, we reduce the base down to a 2, and we knew that 2 to the power of 3 would become an 8. Over here, if I reduce this down to a 4, well, will 4 to the power of something give me 8? There's no obvious whole number I can put here that's going to give me 8, so 4 is not going to work. So what I need to do is actually reduce the base, or get a different base for both of these. So 4, I can bring that down to 2, and what gives me 4 if I'm using 2 as the base? It's 2 squared. So 4 is 2 squared, and I'm going to keep that 3 there on the outside like that. And over here, I've also got a base of 2, and I get that 8 by using what I had up here, that 3. So 2 to the power of 3, and I have to keep that m there on the outside as well. So you can see here I've got 4 cubed. 4 cubed is right there. And here I've got 8 to the power of m, just hidden with these bases of 2. Now over here I've kept the index law that we used earlier because it's going to come in really handy right now. That 3 is going to multiply onto the 2 and you get 2 to the power of 6. So if I just go and do the working here, we get 2 to the power of 6 on the left hand side. 2 times 3 is 6. And here we've got m times 3, you get 3m. So we get equals 2 to the power of 3m. So you can see now that these powers, the 6 is equal to 3m, so what I can do is I can say 6 equals 3m. I'm going to divide both sides by 3. Like this, dividing both by 3, so I end up with m equals 2. So we'll have a look at these 4 more examples here. We've got 3 to the power of x minus 2 equals 27. Well, over here we need to see if we can turn 27 into a similar base. We want that 3 over here on the right. So we've got 3 to the power of x minus 2 is equal to, well, what's 27? 27 is 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, so it's 3 to the power of 3. So what we've got here is x take away 2, or x minus 2, equals that value of 3 on top. Both of these powers are the same thing. So if x minus 2 equals 3, then what I'm going to do is I'm going to take that minus 2, bring it over here, you get a plus 2 instead. So you end up with x equals 5. Over here we've got 4 to the power of x is equal to 1 over 64, so we're looking for a base of 4 over here on the right. So 4 to the power of x is equal to 1 over, now how do we use 4 to make 64? You've got 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. So that's 4 to the power of 3. So you've got 1 over 4 to the power of 3. So what we can do here, we've got that index there, 4 to the power of 3. Now if you remember from the previous video, we could take that whole thing on the denominator, move it to the top, and you'd go and make a negative index instead. So you've got 4 to the power of x is equal to 4 to the minus 3. If you remember that minus 3, if you take it to the denominator, it becomes a positive 3, which is what we had originally. So now you've just got x equals minus 3. Over here we've got 7 to the power of minus x equals 1 over 49. So something very similar, except we're playing around with these negatives now. So you've got 7 to the power of minus x equals 1 over 7 squared. Or you've got here 7 minus x is equal to 7 to the power of minus 2. If you take that index once again to the top, to the numerator, it becomes the opposite sign. So 7 to the power of minus 2. So you've got minus x equals minus 2. I can write that here. And if you've got a minus is equal to a minus, then x must be equal to 2. So we've got x equals 2. Last of all, we've got 3 to the power of x is equal to the square root of 81. So I want to get rid of that square root, so we've got 3 to the power of x is equal to 81, and if you remember, the square root sign could also be represented as a half, 1 over 2. Now we want to turn this 81 into something with a base of 3, so 3 to the power of x is equal to, now I can tell you that that half is going to sit outside, we know that from the previous page, but 81, 3 times 3 is 9, times 3, we'll write that over here, we've got 3 times 3 is 9, times that by 3 is 27, and times that by 3 is going to give you your 81, so there's our 81, equals 81. So over here I've got 3, and how many powers was it? It's 3 to the power of 4. So 3 to the power of 4, and you've got that half on the outside now. That index law meant you multiply that 4 by a half. So you get 3 to the power of x is equal to, 4 times a half is 2, so 3 to the power of 2. So therefore, x equals 2.